Good day, students. Welcome to the GIST experiment, and this experiment is about suspension polymerization of styrene. Now, the aim of this experiment is to prepare polystyrene polymer using suspension polymerization to determine the TG of polystyrene by DSC, Differential Scanning Calorimetry. And lastly, you are supposed to determine the polymer's molecular weight by viscosity measurement using the Mark-Goodwin-Sakurada equation. Now we know that styrene is an olefin with the molecular formula C8H8 and with the structure shown below. Now styrene undergoes addition polymerization as the alkene moiety, giving rise to polystyrene, and this is a polymer with many commercial applications. The polymerization of styrene is carried out by free radical polymerization, a reaction in which polymerization is initiated and propagated by free radicals. Now, this is the most commonly used technique for chain growth polymerization as it is much less sensitive to the effect of advantageous impurities than chain propagation by ionic polymerization. In general, the free radical reactions with the double bond of the vinyl monomers are not as nearly as selective as the ionic attack, hence leading to side reactions. But the resonance stabilization of the styrene due to the presence of the conjugated CC double bond, pipe of the benzene ring as well, allows the use of the free radical mechanism. Now to start off with the free radical polymerization, the free radicals must be introduced into the system, and to do that, we are introducing a thermolabile compound, which we call the initiator. And this decomposes into the free radicals. Now these free radicals attack the monomer, giving rise to a longer chain free radicals, and then continuously produce a longer chain radicals, and then finally when two radicals come together, they form a neutral compound, and that is your polymer. In this experiment, benzoyl peroxide is used as the initiator. Many chain growth propagations reactions are highly exothermic processes, and as the polymer molecular weight increases, the viscosity increases because of the increment in the van der Waals forces of attraction, and these lead to the heat buildup, making it very difficult to control the reaction. But we can avoid this by reducing the amount of monomer to be polymerized, which then can be accomplished by polymerization of the monomer while suspended in a dispersion medium. And this dispersion medium is normally water, and hence this is called a suspension polymerization. The polymer is introduced into the water and the mixture is agitated. As most monomers are insoluble in water, the small monomer droplets are formed, and that acts the micro-reactions vessels where the polymerization occurs, using the polymer in the form of small beads of varying diameter. And this ensures that there's no heat buildup, as the water being used, which has a very high heat capacity, is acting as a heat sink, and hence the reaction can be controlled. The size of the beads formed is inversely proportional to the stirring rate and the amount of protective colloid employed. The following equipments and chemicals will be the one that you'll be using, so check first before you proceed to the start of the reaction. For the procedure, you're supposed to take out 360 ml of distilled water, 0.3 grams of PVA and 0.06 grams of calcium phosphate. You charge them inside this reaction kettle fitted with a condenser, stirrer and thermometer, and then heat it up and flush with a slow stream of nitrogen gas. Now when the reaction mixture has reached 90 degrees Celsius, a solution of 0.3 grams of benzoyl peroxide in 20 grams of freshly distilled styrene is to be added into the reaction kettle, and then you leave it there for 3 hours with continuous stirring. Constant rate of stirring. Remember, stirring never stops. Keeping the temperature at the average of about 90 degrees Celsius. Try not to let it fluctuate so much. And after that, you stop the heating, you stop the stirring, and you leave the reaction mixture to cool. Now, the product beads that's being formed, you are supposed to filter them using a suction pump and clean them using distilled water. Just do a quick wash. Then you place these polymer beads in a crucible and put inside the oven to dry. After 5 days, you have to remove the polymer from the oven and then leave it to cool. Now 0.2 grams of this polymer will be weighed, and then you dissolve them in toluene, which is a good solvent to dissolve your polymer because they're all hydrophobic. Now then you make up this solution to the mark using a 25 ml volumetric flask, and then you place it inside the oven. and another 2 days from then, you filter this solution through your cotton wool into another clean 25 ml volumetric flask to remove any undissolved polymer, because we cannot afford to have any solid when we do the molecular weight test. So after you do the transfer, you top up to the mark again of the 25 ml volumetric flask using more toluene. After that, you take out 10 ml of these polymer solutions, evaporate it over the hot water bath, and then you take the polymer that's deposited, you take it to weigh it, and then record the readings. And after that, you get to employ this Oswald viscometer to make time measurements. Okay. Some of you may be new to this equipment called DSC, so I'm going to give you a short and brief introductions about it. Now, DSC, Differential Scanning Calorimetry, is a technique in which the heat flow rate differences into a substance and the reference is measured as a function of temperature, while the sample is subjected to a controlled temperature program. It is used to determine the transition temperatures in the polymers, the glass transition temperature, which is very famously known as TG, crystallization temperature, TC, and the crystalline melting temperature, TM. The TG is a characteristic of an amorphous polymer, while TC and TM are characteristics of a crystalline polymer. At TC and TM, the DSC can also be used to determine the heat of crystallization and melting from the areas under the graph. The DSC is advantageous because it gives very quick analytical qualitative results. It is also very useful when only a small amount of samples are available. And of course, the instrument is relatively inexpensive. So what happens at TG? At the glass transition temperature, the amorphous phase of a polymer is transformed into a brittle, glassy material into a tough, rubber-like liquid. And this is the endothermic process as the system absorbs heat to produce increased molecular motion. So it's like a worm wriggling way out, wriggling. And as a result, the output curve turns upwards. The process also results in an increase in the heat capacity due to the increased heat capacity of the polymer molecules to convert the heat into kinetic energy by undergoing molecular motion. So what are some of the advantages of suspension polymerization? It enables easy heat removal and control, and the polymer that's obtained is in a form that's convenient, easily handled, is always ready to use. Now, special applications of the suspension polymerization involve it is used in the preparation of polymers such as polysulfides, the PS, polymethyl methacrylate, PMMA, and polyvinyl chloride, PVC. And these are common polymers that surround us in our daily life. You are encouraged to read the lab manual closely over and over again, do some research online, take down your references in your lab report, and discuss about it.